Hey y'all, in this video, I'm going to go over an example where we're going to write the equation of a polynomial when given a graph. We have a graph of a polynomial here, and it says that we're going to assume that the leading coefficient is either +1 or -1. So you have to decide based on the picture which one that is. Now, we already have learned about in behavior and odd and even functions and the in behavior of the functions. So you can already tell by looking at the graph whether it's going to be positive or -1. So that's a good place to start. This is an even degree function because both of the ends are pointing up. Remember, when they go opposite, sorry about the fireworks. When they go opposite, I need to not use thumbs. That was odd. And then when they're the same, it's even. So this is an even degree function. And since it's pointing up, that indicates that it is what? Positive or negative? Positive. So we know off the bat that the leading coefficient is going to be +1, not -1, because of these endpoints. Okay, next thing that you should do is identify the critical values, which are the x-intercepts, and we also need to decide their multiplicity, because multiplicity refers to that exponent on each factor. So the x-intercepts are going to line up our factors of our polynomial, and then the multiplicity is going to line up our exponents on those factors. I have 3 x-intercepts on this polynomial. So I have an x-intercept at -2. I have one at -1, sorry. And I have one at +1. Right here, here, and here. And then the behavior is different at each of those x-intercepts. And I did that purposely so we can kind of see an example of all of those. And what comes into play here is parent functions. So we want to go back and remember our parent functions so that we can decide the multiplicity. That's all that means. So remember parent functions. If we have linear, that's x to the first. That's just a straight line. If we have quadratic, that's x squared, and that's a U-shaped graph. That can be upside down, but the parent function is just a U-shaped graph. And then cubic, that's x to the third. That's kind of like a river a little bit, kind of jogs through is what we talked about. So I have one of each of those in this graph. My x-intercept at -2 is mimicking. If I'm going to isolate it down to just focus on, I'm going to ignore the rest of this graph and I'm just going to focus on that part of the graph. That is looking like a U-shaped, it's pretty narrow, but that's because I have it zoomed in or out, sorry, zoomed out. It's pretty narrow, but it is a U-shaped graph. So the multiplicity, that's going to mimic an x squared, a quadratic function, which means that the multiplicity is 2 because it's at quadratic. That's the exponent on it. At -1, if we isolate it to the x-intercept of -1, it crosses straight through, which is like which parent function? Linear. So this one has a multiplicity of 1, because a linear function has that exponent of a 1, x to the first. And then our last x-intercept, again, isolate it and just focus on that. It kind of jogs through like a river, which is like the parent function of a cubic function. So that has a multiplicity of 3. It's like the parent function of x to the third. So this one was like x, and this one was like x to the third. You don't have to write that on the graph if you don't want to, but I just, for note-taking purposes, it might kind of help. So we had one where it bounces, that's a multiplicity of 2, one where it crosses through, that's a multiplicity of 1, and one where it jogs through, and that's a multiplicity of 3. So if you want to write that down, you can. Might help for looking back at your notes. And then I jumped the gun and I already did number 2. So we're deciding the leading coefficient based on the behavior of the endpoints of the graph. They're both pointing up, and that means even, positive, degree function. So the leading coefficient is a positive 1. You don't have to put the plus in front, but you could just do a 1. And then now we have all the information we need to write the equation of our function. We know that it has to be an even degree because they're both pointing up. We know it has to be positive because, again, they're both pointing up. And then we know that we know each x-intercept and their multiplicity. Now, at this point, I need to make sure that my multiplicities add up to an even number because it's an even degree. So if we were to multiply it all out, my highest exponent should be an even exponent since it's an even degree. So if I look at the multiplicities, 2 plus 1 plus 3, that's 6. 6 is even. So that checks out. So at that point, like if you had put a 2 here instead, and you were to add those up and you're like, uh-oh, that indicates an odd degree, I've done something wrong. It's kind of a checkpoint. So now I can write the equation. And I do that by taking each x-intercept and putting it into factors. Whoops. There we go. So if it were x equals -2, then that indicates that the factor had to be x plus 2. Because if I were to set that equal to 0 and solve, I would get -2. And that one had a multiplicity of 2. And then if it's x equals -1, I'm going to add 1 over. And that was a multiplicity of 1. You don't have to put the 1 there, but I will for note purposes. And then x equals 1, subtract that 1 over. Had a multiplicity of 3. I'm going to call this f of x. It had a coefficient of 1. And that's it. That's the function. You don't have to multiply it out. You can leave it just like that. You don't have to change the order. If it bothers you that the exponents are not in order, you can. You don't even really have to write the 1 since it's positive. 2 squared times x minus 1 to the third. And that's your function. That's all you have to do. And then I would recommend to check it and make sure it actually matches your graph to just check your answer. So when I went to y equals, I typed in my function and I went to graph. Look at that. Hold on, I'll show you. Look at that. Looks just like it. So I know I've done it correct. So that's all you have to do to write the equation of a polynomial when given a graph. I hope this helps. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.